Section 3.5 is a very short section. We are going to be dividing polynomials. So what I'm going to do in this first example is long division, and I have to the right of this an example where we are going to review how to do long division. So if I start at the one on the right, I start out and put the denominator on the outside, and I put the 631 on the inside. So we're going to do the exact same thing with our polynomial. So I have x plus 3 is what I'm dividing by, and then x squared plus 10x plus 24 is what goes underneath. Now the question I ask myself is, how many times does 4 go into 6? Well, it goes in one time. Now over here you've got a little bit different question. You've got to take x squared and you're going to divide it by x. So if I have x squared and I divide it by x, then the answer would be x. Now, I'm going to take this top x and I'm going to multiply it first by x, and that answer will go here. And then I multiply that x that's on top by this 3, and that answer will go here. So when we do x times x, we get x squared. And then when we do x times 3, we get 3x. Now, I'm going to come over back to the other one. So I have 4 goes into 6 one time, and then I do 1 times 4, which is what we did with our polynomials as well. So I have 1 times 4 is 4, and then we subtract. So when I subtract, that gives me a 2, and I bring down my 3. So if I come over to my polynomials, what I have to do is subtract everything beyond. Now sometimes kids will get confused and leave that negative off. So if you're prone to do that, if you think you might forget, then you might want to take the time to put a subtraction there and go ahead and erase this and put that subtraction there, and that's the same thing as distributing the negative. So as I do this, I subtract x squared minus x squared, and that goes away. And then I have 10x minus 3x gives me 7x. And just like we did with the 3 in the one on the right, we will have to bring down the number 24. At this point, I am going to flip back over to the numeric one. So now I'm asking, how many times will 4 go into 23? So 4 goes into 23 5 times. So for us in the polynomial section, we're going to have to ask, how many times will 7x be divided by x? So 7x divided by x is going to give me a 7 right here. And in the same way that we have the 5 in the one on the right, we do 5 times 4, and that gives me 20. So what we're going to do now is take this 7, and we're going to multiply it by x right here and 3 here. So 7 times x is 7x, and 7 times 3 is 21. And then we will come back over here and subtract, so we get a 3, and we bring down our 1. And then for us, we are going to subtract, so this will become a subtraction, as does this. And when I subtract, I have 7x minus 7x, of course, goes away, and I have 24 minus 21 gives me 3. So I'm coming back to my numeric. So the next thing we ask is, how many times will this 4 divide into 30? And that would be 7 times. That gives me 28, and I subtract and get a 3. So this is our remainder, and this would be our quotient. In the exact same way that this is our remainder, and this is our quotient. So the process remains the same on both sides. Now, before you get nervous about you didn't follow all those steps, we're going to do several examples together. I'm going to go through this slowly, and then if you have questions, of course, you're going to come and see me. So now we're going to work through one where we're missing something. So we have 2x squared. We're missing the 0x term, so we have to put that in there as a placeholder, and then plus 5. And then what we're dividing into is 2x cubed minus 14x squared plus 7x minus 33 So we're going to divide this by looking at 2x cubed divided by 2x squared. So we're going here, this divided by this. So 2x cubed divided by 2x squared is going to leave us with x. Then we multiply the x times 2x squared, so that's 2x cubed. Then we do x times 0x, and that's 0x squared. And then we have 5 times x, which gives me 5x. Now, I have to subtract that, so I'm going to change this to a negative, going to change this to a negative, and this to a negative to show that subtraction. So I have 2x cubed minus 2x cubed cancels out. I have negative 14x squared is left when I subtract here. 7x minus 5x is 2x. And then we're going to pull down our constant, which is negative 33. Now we're looking at dividing negative 14x squared by 2x squared. So when I divide those two, I end up with negative 7 up here. And I multiply negative 7 by everything on the outside. So that gives me negative 14x squared plus 0x minus 35. And then, of course, we have to subtract that line. So this becomes a positive. This would become a negative. And this would become a positive. So the 14x squareds are gone. I have 2x plus 2 is my remainder. So your quotient is at the top, your remainder's at the bottom. So quotient would be x minus 7, and then your remainder is the 2x plus 2. So long division can be a little bit tedious. There is another alternative. You have to check two different things for this. Number one, the degree of the denominator must be equal to 1. And then the second thing is your leading coefficient must also be equal to 1. So since that works on this one, I'm going to show you what these steps are. Synthetic division goes a little bit easier. You don't have to go through all of the same steps, even though you come up with the exact same answers. So we will have, the first thing that you do is after you check these two things is set the denominator equal to 0 and solve for x. So x would be equal to negative 2. That number goes in the box. The next thing I do is take my leading coefficients in order, make sure it's in descending order. So my leading coefficient is 1. The 1 on x squared is 3. The 1 on x is 9. And then your constant would be 18. Again, if you have one that's missing, you have to account for it, so you would put in a 0. Now, we're going to skip a line and draw a line. In this process, you're always going to pull this first number down. It can be a 1, it could be a 4, it could be a negative 3. All right, it can be any number, but regardless what number it is, you pull it straight down. Now, at that point, I multiply 1, because that's the number we brought down, by negative 2, because that's the number in the box. So you multiply. So we've got negative 2 times 1 is negative 2. And now we're going to add that. So 3 minus 2 also gives me a 1. And then I go back to my multiplication. So again, I'm going to multiply what I pulled down from the subtraction by what's in the box. So for me, I have a negative 2 times 1. That's going to give me a negative 2. And then again, I add this. So 9 minus 2 gives me a 7. And then I multiply the 7 by what's in the box. So that's going to give me a negative 14. And that goes here. And then I add one more time. So 18 minus 14 is going to give me 4. Now, I draw this line right here because what's beyond it is my remainder. Now this time my remainder is just numeric. I don't have to worry about a variable x because it doesn't have one. Now, this is where the last part comes in. In order to come up with the quotient, you have the coefficients on each term from these numbers right here. So I have a 1, and a 7. Now, we usually don't write the ones, so you can take these out as you type the answers in. But what we need to do at this point is look up here at the top and look at what our original degree was. Our original degree was a 3. Now, this quotient is called a depressed polynomial. Now, the reason it's called depressed is because it has lost one of its degrees. So originally, these numbers were a degree of 3. So now these numbers are a degree of 2. So this is 1x squared plus 1x plus 7. So we would write our quotient as x squared plus x plus 7. As we look at this next one, number 1, the degree of our denominator is a 1. All right, the degree of the denominator is equal to 1, so that part checks. And then the second thing is its leading coefficient, a 1. It is. So the next thing we're going to do is take the bottom, set it equal to 0, and solve for x. So x is going to give me a 6, and that's the number that goes in my box. Now, at this point, I'm looking at the degree of what I'm dividing into, so it's a third degree polynomial. So the leading coefficient is a 1. The 1 on x squared is a negative 4. The 1 on x is not there, so I need a placeholder of a 0. And then my constant is negative 77. Skip a line, draw a line, and pull down this very front number regardless what it is. Then I multiply the bottom by what's in the box. So 6 times 1 is 6, and then I add. 6 minus 4 gives me 2. And then I multiply by what's in the box. 2 times 6 is 12, and then I add, which gives me a 12. And then I multiply by what's in the box. That's going to give me a 72. And negative 77 plus 72 is negative 5. And I know that what's out here is my remainder. And then my quotient, of course, is the depressed polynomial. So I have 1x squared plus 2x plus 12. And you will not want to type that 1 in when you type it in online. Looking at our last example, I have a degree in the bottom of 1, and the leading coefficient is a 1. So I set x plus 1 equal to 0, and I get an x of negative 1. So that's the number that goes in my box. Then I look at what I'm dividing into. So the leading coefficient is a 1 on a degree of 4. The term that has a third degree in it has a coefficient of negative 2. X squared is missing, so I have to have a placeholder. X has a coefficient of 8, and my constant has a 6. So I skip a line, draw a line, and pull my 1 down. Multiply by what's in the box and get negative 1. Negative 2 minus 1 is negative 3. Then I multiply by what's in the box, and I get positive 3. Add that to 0 to get 3. Multiply by what's in the box to get negative 3. 8 minus 3 is the number 5. 5 times negative 1 is negative 5. And 6 minus 5 is 1. So my remainder is the number 1. My quotient, of course, is this depressed polynomial. The degree of what I was going into at the beginning was a degree of 4. This will have a third degree. So this is x cubed minus 3x squared plus 3x plus 5. See me with questions.